My name is Alina, and I'm here with Daniel, our local GraalVM expert, as you can tell.
Spring expert.
And we are here to talk with you about all things migrating to Spring and GraalVM, why you would do so, about easy-to-migrate scenarios, not so easy, how you can build your app, how you can break your app, and all things about it. Let's go. So seriously, though, I work on GraalVM at Oracle, and Daniel?
I work in the Spring team for Broadcom, and I focus on Spring security, but we do get to do many more things.
Exactly. And in this session, we will talk, as we said, about Spring and GraalVM. So right now, it's very easy to build applications with Spring and GraalVM, specifically since the Spring Boot 3.0 release, when there was introduced general availability of native image compilation. You could have done so before, but now it's even easier. So it's available out of the box. If you're building an application with Spring, especially if you're building a new application, your migration path will be very smooth, and there are many ways to build such an application and many benefits to get from it that we will hopefully cover in this session today. OK, so we want to show you an app that just works, TM, as you can tell. So let's start with an app that just works, and then we will see how we can also break things. So let's start with our first application. You might know that there is somewhere around here at the moment also a Spring AI session happening. So guess what? We also have Spring AI at home. So hopefully you're not losing that much.
That's how we got in here, right?
Yes, that's how you need to do AI to get into a conference these days, right? So let's run the app. We will run it in 2 modes, and then we will see what it actually does. First things first, let me check my Java version. And I'm here on Oracle GraalVM version 23. Who else is on 23 already?
Let's go. We see
some
you.
Some people. I'm happy that Daniel is as well. So GraalVM is a JDK. It can run anything that any other JDK can run, but it can also run more and better, if you ask me, right? So that being said, that it can run anything that any other JDK can run, let's just run our application with a normal Spring Boot JVM mode and see what it actually does. So it runs, and I must say this runs on a cloud machine, a fairly decent one. So it has many resources being available to it, but still it starts in about 1.7 seconds. Now let's go to our endpoint. Yeah, this was running before because we were testing. So here is our Spring AI application. So it's a travel recommendation app that will use Spring AI to give us recommendations for our user where they can travel to or what they can do if they cannot make up their mind. So let's say we want to travel to Belgium, because that's where we actually are. And as activity, maybe we want to do hiking, because,
Very known for hiking, Belgium.
Yes, popular destination for hiking. And let's say we are feeling adventurous. Let's go. So let's see if we can manage to do so in Belgium. And I would need Daniel's help reading this, what looks like French toponym to me.
Of course.
Yeah.
Les Ardennes, un petit tour dans les Ardennes. Very good.
I could never do it, but you can trust Daniel. Also, if you're local, you can tell us if that's a good destination for hiking in Belgium. So our application started, and it runs on GraalVM, but where is fun in that, right? So let's make it native to make things more fun. So to make things more fun, let's go to Josh's second favorite place, which is start.spring.io. And let's say we want to move our application to native. So we have an existing app, and we want to make it native. So how would we go about it? First of all, I want to add a dependency. And look at that. At the very top of my list, there is GraalVM native image. Very convenient. So if I go here, and I don't need to generate because I have an existing project. So let's just explore and see what makes this project stand out. And the part that I actually need is this native Maven plugin. So let's copy the plugin so we can move our application to native as well. And let me move this down. And let's see, here are my plugins. And here goes my native Maven plugin. Now, I will trigger the build, and we will use the compilation time to talk more about this application. So Maven, be native compile. And now it will run, and it will build my application as a native executable with GraalVM. So a few things I want to add here. First of all, if I was back at home just working on this application, I would have added a number of things here. So what I can do here is I can add a configuration block, and this is the place where I can specify all the settings for my build. And one of the first things that I would have added as I'm still working on this application, I would have added the -OB flag, and that gives me a quick development mode. So this says I'm not deploying my application yet. I'm still developing. I want faster iteration times. Don't optimize for production. I don't care about that yet. Just give me my build faster back to me. I would also specify the name just for my own convenience, but just to show you there is no magic to be done there, it will just compile this way. And also, as I'm compiling those applications at conferences, people often tell me, you know, Alina, it runs so long. Why does it have to be so long? I don't have that attention span. Jesus Christ, please do something about it. But look at this. So my application is not that large. It has maybe, 3 classes, but it does have JDK, Spring, my dependencies, etc. And even this fairly trivial application under the hood contains, where is my analysis phase? Yeah, so it contains almost 120,000 reachable methods. So Java and all the frameworks and dependencies give us great developer productivity, but it comes at the cost that there is a lot of complexity underneath. There are many things coming together, being resolved to make this project come together. But
it's cool because your computer gets really, really hot when you compile. So in the winter, it's great.
Unless you have an ARM MacBook, but that's, you know,
It actually gets
you're
warm.
out of
It
luck.
does get warm.
But with that being said and done, our application finished compiling. Even without the quick build mode, it's still compiled in 1 minute 30 seconds, which I would say is decent. And let's just validate that it does the exact same thing. So it still runs and it does what we expect it to do. So remember previously it started in 1.7 seconds. Now it just starts in 53 milliseconds. And if we go back to our endpoint, where was it here? And we go back to the home page, we can, again, travel somewhere. So let's say you want to go to Antwerp. It's a city, not a country, but the LLM is smart enough to figure it out. And let's say we want to go for beers, as one does. And let's say we are still feeling adventurous. So let's see if we can get
That
Beer
must be-
Central
yeah,
out of...
Beer Central.
I don't think it's smart enough. So what does it say? The Conning Brewery? First time I heard it, but maybe we can explore it. So anyway, our application still works. Does the same thing as on the JVM, but you can say that it starts much faster. And also if we do quick, well, not benchmarking, but let's say we want to explore our application a bit more, and let's say we are curious about how much memory does it use. So if I go here and I sort by my RSS, here is my target demo running at 111-ish max of RAM. Granted, it is idle at the moment, but it's fully available and it's ready to be doing what it's supposed to be doing. So I would argue that this memory footprint it might be one of the main benefits why you might go with native image.
Yeah, it's about a fourth of what you would get for a Spring application. If you've ever deployed Spring, you at least give a 500 megs, sometimes more, for a faster startup.
For sure. So quickly about how is this different from running on hotspot. We have seen already that my application now starts much faster. Also, it uses way less memory. So where this is coming from, it's coming from the fact that we offer you a trade-off where you can move all that work that the JVM normally does at runtime. You can move it to build time and do it once, as opposed to do it spread out throughout runtime every single time you run the application. So you build it once, maybe a bit longer, but then you can start pretty much instantly and also consume much less resources.
My MacBook is hot, but my servers are cool.
Very nice. So 2 things to keep in mind here. It's ahead of time compilation, meaning the runtime hasn't happened yet, so it has to happen under closed world assumption. So everything there is to know about your application needs to be known at build time. And this is important thing to remember about native image. Later on, we will show you different ways to break it or cause challenges for it. But native image can do pretty much anything for you as long as you instructed what exactly needs to happen. So as long as you make those things visible to native image at build time, it can do pretty much anything for you. Now, speaking of closed world assumption, there are some limitations that come with it, and they're not necessarily associated with native image as much as with the whole ahead of time concept of compilation itself. So those more dynamic Java features, namely reflection, serialization, resources, proxies, etc., they work in native image, but native image needs to be instructed about them to make them work and include them at build time, because again, the runtime hasn't happened yet. So the way this is resolved at runtime, usually on the JVM it's runtime, but in native image, using config files, you can instruct it to include those features in your native executable. Now, how this can happen, especially if you want to use libraries. So if you want to use a library, and that library is using reflection and a more sophisticated kind of reflection, there are many ways how to make it work in native image. The best case scenario is if a library itself ships config for native image within the library, then things just built for you as a user, you don't even notice, they just automatically magically resolved at build time. So if you're a library maintainer, the best thing you can do is include config within the library itself. Now, if that somehow is not an option, another thing you can do, you would think that there could be such thing as a, let's say, Maven Central, kind of, where we can store the necessary config for native image and all the different libraries. And indeed, we saw the same thing, and we created such place on GitHub, where users and maintainers can contribute config that can just be automatically consumed by native image if you're using one of the frameworks that works with native image, such as Spring Boot. To finalize this thought about libraries, we have this page on GraalVM website, where we have a very, very long list of libraries that are known to be continuously testing and building with GraalVM and ensuring that all those things work. So if you want to quickly assess whether your project will build with GraalVM, this is at least a list of known libraries that definitely will work.
And you can contribute to this. So we improve test container support.
Such as Daniel contributed to make test containers work again on native image. Thank you, Daniel.
Yeah, and the GraalVM team is very, very friendly and helpful in helping you contribute. So, go ahead, add your favorite library to you.
Happy to be of service. So let's say we want to migrate an application, and I showed you like a best case scenario where you're migrating a new application. So if you're using Spring Boot 3.0 and higher, things will just work for you. So as a first step, you need GraalVM JDK if you will use native image, because it's specific to GraalVM JDK. Then please migrate to Spring Boot 3 and higher. It will help you build applications and use all the libraries significantly.
I'm not going to ask who's on Spring Boot 2, because you shouldn't be on Spring Boot 2. It's out of open source support. So you should be migrating anyways, and you have tools to do that. So Open Rewrite in Spring, in the enterprise products, we have the Spring App Advisor. So take that as an excuse to migrate your dependencies forward.
With that, let me switch the cable to my co-speaker.
Thank you. So as Alina mentioned, latest versions use the -OB flag in compilation. Is this coming up?
No, yes.
You can shave off 30–40% build time. So when you are migrating an existing application, you add this, and it will make the process much smoother. You remove it when you go to production. So to do this talk, we had an app, and we migrated it. But the real-world app, they tend to do a lot of things at the same time. So for a demo, it's not great, because many things break in the same place. So we decomposed this app into a toy application. So it's called Examples. It's in here, and I built it with Gradle. So here we have Team Maven, Team Gradle, but we're still friends. That's fine. And so Examples, and the task is native compile. So when doing this, you notice that we will get the GraalVM native image compiler that is starting to generate my app. But before that, you see this Spring Boot banner. And this is part of the process AOT task, so the step that comes before GraalVM, because GraalVM needs to know all the code that goes into your application. It does that by scanning through your main method. Spring needs to know all the beans you're going to be using in production, but it decides this historically at runtime. So it's too late for the GraalVM compiler to figure out, oh, I want this controller, I want this service, and so on. So we added an extra step of compilation that brings up your bean graph. It finds out all the beans you're going to be using, and then it's going to generate code so that the GraalVM compiler, the native image compiler, knows that you want to use this. So here in my examples project, in build, generated, I have AOT sources. And in here, I have a bean factory registrations. This is a big class that contains the list of all the beans that are going to be included in my app and methods for constructing them. So for example, I don't know, I have an index controller. How do I construct it? I construct it by calling new. But this means this code is visible to the native image compiler, so it will be included. OK, so over time, then this should be compiled. So 113, very good.
Bad.
Not bad, yeah, not bad. And so our app, as we've seen with Alina's app, usually it kind of works when you start it. It's able to boot. You're not finding many problems at compilation or startup. So this is because Spring helps you. So Spring has this AOT thing that scans your code and decides what should be in there. It also helps you add more stuff to it, we'll see, and also because you're using Spring Boot. And Spring Boot has a list of curated dependencies that you don't manage yourself. And all these, we try and contribute to the GraalVM reachability metadata repository. So if you're using Hibernate in the version that we support, there will be metadata in the repository. And so you should be safe about it. So the main question Alina gets when she gets to a conference or criticism is reflection. Reflection doesn't work in GraalVM. So Alina, is that true?
That is not true. Reflection does work in GraalVM, but there are things to know. So first of all, you can run applications on GraalVM as JIT, then you can do all reflection you want. Now, when it comes to native image, there is an out-of-the-box support for reflection in native image. There is the kind of reflection that will always work without zero config, like no config at all. You can see examples here on our slides. Those are more like, let's say, predictable, simpler things. So things like class for name, get field, etc. Native image can detect those calls at build time and provide config out of the box. Those will work. But now, if you want to do something more sophisticated or something in which resolution only happens at runtime, again, you need to instruct native image about those things. And those instructions, or as you call them on the framework side, hints, need to come in the format of JSON files.
So Spring, the AOT compiler, generates one of these files for me. So it says, OK, here's the reflect config, and here are all the beans that I'm going to be using, and the Spring something, something. So a list of things that you will be needing in your app. We do it for you. You don't have to write this yourself. Does anybody here know in which case we have these reflection calls that pose problem? Anyone? And there's a hint on the slide. There's a hint. Come on. Come on. Can you see it here? Yeah, yeah, yeah. It's also here and here. These magic strings, which when you think about it, it's a string. I read it. From there, I infer which code must be loaded and executed. And that's reflection. So let's see a few examples where this may work and where this may not work. So I think my examples is running. OK. This is a time leaf template that's rendered, and it works. It's a string, but it works. I can even use code in it. So in here, this page is generated at 14:17:08. If I refresh, the time changes. So this, even though it's strings and code, it works. Let's look at the index controller. So in here, I have a model. I add the date to the now variable, and I can consume it in my template, and that works. This is fine. If I do slightly more complicated stuff, then this is where I'm starting to have problems. So here's a template, another template that I render, and when I click on it, I get a 500 error. So this is my first blocker migrating my app. We can go here. I'm going to zoom out a little bit so I can read the stack trace. OK, error here. So error in template, that's called templating.html. The method title cannot be found on the type book. This template, good name, I'm proud of my naming, so is a thing that iterates over a list of books, and it calls the title method on it. These books, they're records, so simple thing that has a title method on it. When you think about it, the timeleaf engine is reading this string, and it says, this is code, I must evaluate it. OK, this is a book. All right, this book, does it have a title method? Can I call it? I want a string out of it. So in here, it's doing reflection. So we need to instruct GraalVM, or the native image compiler, that we want this type, this book here, to be registered for reflection. So I could go in the reflect config JSON here and write, but then I need to know the syntax. I need to get my strings right. In Spring, we provide some helpful tools to let you register this and not write strings, but write Java type-safe stuff.
So what we will show now, this will be a programmatic way to generate those hints for native image. So for the context where we said about how we will break things in many places, we are going from best case scenario to worst case scenario. Let's say you have some reflection that needs to happen, and it's not a library that has a config, or there is no config on GitHub. So what is the next best thing you can do? And the next best thing you can do is programmatically generate those hints for native image.
So we register this, and then the AOT compiler will make the JSON for you. And this you can put on any class that is a configuration class. So the Spring Boot application through meta annotation is a configuration class, but you can put it anywhere. And by doing this, the next time I do a compilation, I'll have the book class here registered for reflection, and it will work. There's another place where we have magic strings, where there's code in them, and there might be a problem. So I'm a security guy, and in Spring Security, we have method security with that at pre-authorized, post-authorized. And in here, I'm referencing a bean called authorization service and calling is allowed on it. So the same mechanism is happening here. The expression language processor is reading this and deciding what to do. Prior to Spring Boot 3.4, so 3.4 milestone 3, this did not work. But in the Spring security team, we've put up the work to scan this at build time and add the hints for you. So this used to not work. So if you're using Spring Boot 3.3 or earlier, this will not work, and you need to register this manually. If you're using the latest version, it's better. See? You should migrate. So we could register it here, or we can use a more complete API. So in here, we can import runtime hints, and we are going to create this class. So example runtime hints.class. Perfect. IntelliJ help me out, generate the class. You can see it implements runtime hints registrar, which has one method, and it exposes this hint object. And with hints, I can better control what goes in reflections. For example, here, we want the authorization service, I think, yeah. And then I can tell it, well, what do you want to register for reflection? Do you want to register maybe just the public methods? So I want to be able to call the public methods. I want to be able to, I don't know, get the constructors, right? Or you can say, well, I'm going to register everything. A bit scattershot. I get a little bit more code in my image than what's required, but at least I'm sure it's going to work.
And one more nice thing about this approach is it's more flexible, but also you might have noticed already as Daniel was writing code that it lets you generate hints for reflection, but there is more in this API. So in a similar fashion, you can generate hints for resources, GNI, and all other things. So you can have this one configuration part of your code, but you can generate hints for all the things in your app.
Right, so resources, files that need to go in my app, proxies, JNI. Does anybody use JNI here? Absolutely zero. OK, so it's here if you need it. OK, cool. And then one less place where there's code to string or string to code is, of course, serializing, deserializing to a text format. This happens often in JSON. Probably some of you here are still stuck with XML. I'm sorry for you, but it's still the same thing. So we take code, we make text out of it, or we take text and we make code out of it. So for example, reading JSON when I connect to a web service. So JSON controller, I have this read endpoint, and it uses a Spring REST client. Let's go here. So I get this payload, and then some JSON comes over the wire, and I'm going to map this into the remote API data class. So the Jackson deserializer needs to figure out, OK, that's a JSON property. It's called title. So in this remote API data, I'm going to look something that looks like titles, so I can put the value of title in the value of this class here. And this is reflection. So this is going to fail. Let's put a little bit of space so we can find our stack trace. In here, read JSON. So it does fail, 500. And we get a message that tells us blah, blah, blah. There we go. So it says type error, remote API data, cannot construct, blah, 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 cannot deserialize. And then this appears to be a native image, in which case you may need to configure reflection for the class to be deserialized.
But what a nice error message.
Right, so at least you know what you should be doing here. So this remote API data, you need to register it for reflection. So you could do it in the configuration class with your either in your runtime hits here or this register reflection for binding. Here we're doing centralized configuration. So in one place, I know everything that I register. Maybe you want to do it at the type level, so closer to the thing that needs to be registered. In that case, there's a new annotation, reflective scan, which enables scanning all classes to verify that which ones you want to add for reflection. And so in my controller now, my remote API data, I can tell it, OK, this is reflective, or more specifically, register reflection for binding, which is going to say, OK, everything here is going to be text that goes into a Java class. So same mechanism, but registered in a different way. So reading text and making Java instances, that's not that you have to instruct the native image compiler about it. The other way around, so having a Java class and making text out of it is the same problem. So here I use an object mapper, but if I have a REST client and I write a body in that REST client, if I do a post, I'm going to take this class, I'm going to read the properties, and it say, oh, it has a title, so I need to generate a JSON property title. And so you're going to have the same reflection problem. So this write value of string, again, put a few new lines here, and then we get the same problems here. So in here, 500, and we would get a similar error message, blah, blah, blah. This is a native image. You need to register the book to serialize type. So in that case here, I'm going to leave it so we can see some failures later on, but you could register it here, sorry. There's a third way of producing JSON, which is if your controller is a REST controller, or if you're returning types, not strings here. This, let's take a look at it. This works. So why does this work? This is because this is a Spring managed controller. We know you're going to return a type that goes turned into a string. So if you do this, we know, and we're going to register reflection for you. Same if you map some data that comes in into a type, we know in the signature you're going to be doing reflection here. So the AOT compiler registered this for you. So if we look at this in the reflect config here, this is already registered for me. I don't have to do anything manually. OK. Amazing. So a little TLDR that. Beware of code in strings. Beware of serializing, deserializing to a text format, JSON, XML, whatever text format you use. And if you use third-party libraries that do this, well, they will have the same issues, right? You will need to register stuff for reflection. In Spring, we have many utilities, so you have to go and write JSON manually. So import runtime hints, register reflection for binding, reflective scan if you want to invert where you register your things. Everything that's a Spring Bean, if you have public methods, that's covered. We will register whatever you need already in the compiler. And then method security with Spring Security, that's covered in the next version of Spring Boot 3.4. If it's in 3.3 and you're doing magic evaluation here, you may have to register for reflection manually. OK, so a little bit on testing.
Your favorite topic.
Yes, my favorite topic, right? I did 3 hours deep dive. Anybody come to my deep dive? Hey.
Oh, wow, half of the room, man.
So why is testing useful here? Because when I'm migrating a big application, there's many things that I may need to change, register, and be aware of. And so if I make a change and then I have to recompile my app and then go, click, log in, then it's a bit painful. So the idea is to run automated tests that touch your app for you, that exercise these endpoints, these methods, and the Gradle task is native test. So if I run native test, it's going to do the same as it does for the main app. So here it processes AOT, then it runs the tests to be sure that you don't need to compile to native. If your tests are already failing in JVM, then probably not worth running them in native. Then it runs the native image compiler. And it produces a binary that runs your tests. So it's not your app, it's a test harness that you launch. There is one limitation here, which is mockbean, spybean. So in framework 6.1, in 6.2, this has been renamed as Mockito bean, test bean, but it's basically the same thing. So if you're using Spring Boot 3.3, I have a Mockito bean test here. This, having a bean that I swap in my tests, would fail. So it would work nicely on the JVM, no problem. I run this test, it works. If I run it in native image, it doesn't work. So to overcome this issue, if I have some tests that are like this, what I can do is say, well, this test here, I don't want it to run in native image, disable it in AOT mode. On the other hand, maybe I want to have some specific end-to-end tests that I run in native image to make sure that I touch everything in my app and that all reflection is correctly registered. So in that case, you can say, well, this specific test is only for native image because maybe I deploy my test harness to a server to test a few things. Well, I can decorate the test with enabled in native image. This is a JUnit thing. And the test would only run in native image. It doesn't run on the JVM. So in here, this test is ignored. So let's see our test results. So it has failed, as expected, because we didn't register this book to serialize thing. It ran the tests. It gives me a little update in the end. So we found 4 containers, 4 test classes. 1 was skipped, the one that was disabled in AOT mode. Found 7 tests. We skipped 1. 4 was successful, 2 failed. And so if I zoom out again a little bit, here is the failing test. And it says, well, no properties for book to serialize. This appears to be a native image, in which case you need to configure for reflection and so on. And so you can go and fix your issues the same as if you had compiled your app and gone and clicked. So all I told you here about Mockito not supported, of course, our good friend Sam from the JUnit team and Spring team, yesterday, October 8th,
As Daniel was peacefully having his speaker dinner.
Right. It's now supported in Spring Framework 6.2. So in Spring Boot 3.4, Mockito Bean will be supported for interface mocks, not full mocks. And of course, so Alina is much more on Twitter than I am. So she screamed like, yeah, it's working now. And Sam was very happy to interrupt my speaker dinner, so I have to go and rework my demo to tell you that this works now, and you should be happy about it. So takeaways from this: you can run your Spring tests. Don't use Mockito Bean, Mock Bean, Spy Bean yet. And you can control tests in AOT mode. So what you really want with these tests is have good functional coverage that touches the whole stack of your app and exercises everything so that you can migrate easier and that you can be sure that nothing's broken in the middle. Maybe you write dedicated end-to-end test. If you're doing normal testing, you won't necessarily be doing that in native image, right?
Right. So our general recommendation for testing and for developing applications with GraalVM native image is the following, is that you keep developing and building and testing your applications on the JVM, and then you build to native in a number of cases. So one is when you introduce a new dependency and you want to make sure that your application still works, that the dependency is compatible with native image, then you would compile. Then if you're attaching things that you know are sensitive to native image, so reflection, serialization, resources, etc., in that case. Other than that, you maybe want to test in compile to native in your CI/CD or once a day just to make sure you're fine. But you do not necessarily need to compile to native all the time as you're introducing changes to your business logic, especially if you're on a version of a framework that is compatible with GraalVM and that creates libraries for you. You just keep developing on the JVM, and then you build and test to native once in a while to make sure that things work, but you don't need to recompile every 5 minutes as you're introducing changes to your code.
So what we're saying here is don't test a native image all the time. We're not saying don't test, right? Don't go to your manager saying, oh, Alina and Daniel told me it's fine not to test. Test responsibly. Do your TDD. That's great. Do it on the JVM. Native image test serve a purpose. Use them for that purpose. OK, one last Spring-specific bit. So you know that Spring does dependency injection, is very dynamic in nature based on the properties, based on the profiles that I pass, the environment my app runs in. Then maybe I have different behavior. So a little demo here. We have a beans controller. And this controller gets 2 beans injected, a language service and a mood service. The language service, it's an interface, has 2 implementations, the English language service, the French language service. I get the French language service when the profile is French, and you get the haricot français. Un haricot français, it's a bean. And then if you have no French profile, then you get the English bean, because it is not French. And so this is dynamically loaded at runtime. Same goes for stuff that is loaded through a property. So here we have a mood service. The mood can be app.mood. It's a property, and the value can be sad. In that case, you could do sad service, right? But by default, we give you the happy service, because we're fun and clean and helpful. So this you can configure by passing, say, a config file, or in Spring, you can also change the environment by passing properties. So here's my app.mood. I set it to sad. Spring profiles active to French, and we're at Devox, so let's use Devox. And I run my examples, build, native compile, and examples. So I run this. I go to this page, and I can go look at the conditionals and profiles. So the profiles are French and Devox. They're picked up. The mood is sad. OK, this value is picked up. But we get an English bin, which is unacceptable for the French profile. And we get the happy service, but the mood is sad. When you think about it, if you go back to what we said with the AOT compiler, the beans are not discovered at runtime. They're discovered at compile time. So I didn't compile with the French profile. I don't get the French language service. I didn't compile with the app.mood equals sad variable. Then I get the default happy service. And this you would see in your registration, your Bean factory registrations here. There's no language service or mood service. There's directly a happy service, directly an English language service, because this is what was included at build time. So that means if you have profiles and stuff, or if you have these conditional on properties, which Spring Boot uses a lot, you need to use the correct properties matching the build you want to do output, the behavior you want to do at build time. So for example, Spring Boot looks at your application properties and it says, oh, if you have a Spring security OAuth2 client registration, I enable OAuth2 login. You need to set those properties at build time. You don't need to set the right values. We're not connecting to your database at real time. We're just evaluating the condition, saying, OK, you have this. Even though the value is placeholder, we know we should activate these beans so they end up in the binary. So avoid these conditional on properties and profile if you can't. If you have, say, you have a staging environment which is substantially different from your prod environment, and you want to do you don't want to do two binaries. You want to test your real binary in staging. What you can do is you can hack around this. So we remove the component and profiles here. We're going to make this a configuration class, configuration. And then we're going to provide this as a bean. So how do we do this? We do add bean, and then we provide a language service. And in here, at runtime, we can inspect the environment the application is running in. And the environment holds the properties. Thank you, IntelliJ. Environment, there we go. Get active profile, so we can see the properties, we can see the profiles, and with this, we can say arrays as list. And does it contain French? And if it contains French, return a new French language service, and in here, return a new English language service. So if I compile this, then the bean that's loaded at build time is this. And so GraalVM will be instructed to embed the two classes in the native image, and I can go back and have some dynamic behavior by doing that.
So this is slightly hacky, but this was going back to what we said, that native image can do pretty much anything for you as long as you find a way to tell at build time what needs to happen and what needs to be included in this native executable.
So TLDR for this, all the annotations that select classes dynamically based on conditions, avoid them. Profile, conditional on, blah, blah, blah. Other annotations are fine. Value, we saw it picks up the value because it's just text that it puts in a value. And unconditional annotations, a controller, repository, and so on. That's fine. We will pick that up. OK, but that's my code, right? And I know you. I know in here, in this room, there's someone that works for a bank. And that person needs to produce an Excel spreadsheet.
Yay.
Of course, we're working for a bank. And so I have another application that has an Excel spreadsheet in it. Build, native compile, books. So this is my book collection. Refresh, no beans, just books. So my book collection, and I've done the work to make sure that reflection works, everything is fine. But then I have this export method. When I click on it, I get an error. And because this long stack trace tells me this org Apache XML beans implementation store locale is not found. It wasn't embedded, and it's pulled through Apache POI, which is the reference for generating Microsoft Doc or Excel documents. And so if you want, you can go and register this type for reflection. I guarantee the next time you run it, you'll have another problem. And then you register that thing, and then you'll have another problem, and another problem, and another problem, and you're going to have a very, very, very long and boring week. So instead, we should try and automate this, right?
Yes, there is a better way to do it. We will show you in a second. For that, though, I want to say a bit of context. So we're getting really into the woods, right? We explored all other options, more optimistic scenarios where things just work, or you can generate hints programmatically, or you can just pull config from GitHub. So what to do in the case where none of those is an option, because that's some third-party library, so you don't know exactly how that reflection works there. You could try and go ahead and annotate with Spring annotations, but it's somebody else's library. So how do you fix somebody else's library? So luckily, there is a semi-automatic way to produce configuration for native image, not fully automatic, but semi-automatic. So native image comes with a tracing agent that can observe your application behavior at runtime. So the way this works, you need to run your application on the JVM with the agent attached to it, and then the agent will look at your application. Now, note that here you need to apply relevant workload, so you need to instruct the application what it needs to be doing specifically to show us all those code passes that needs to be executed and tracked by the agent. And then the agent will look at what your application is doing, specifically in terms of those dynamic Java features, and it will produce those JSON configuration files for you that you can then feed into native image.
Look, this beautiful Excel. Makes
Amazing.
you happy, right? Warms your heart. So on the JVM, it worked. The agent observed my code, and so I can now stop it. And in my build directories, in books in here, and build native agent output, use the boot run thing. It generated reachability metadata.json, which is the new way of registering reflection and so on. And
this
so
is a fairly large file, right? Because it tracks everything. So it's not exclusive to those things that are breaking. It just tracks everything just in case.
Right. So all the Spring stuff that is used is going to be in here, and it's going to get merged anyway when you do the compilation with the hints that we provide. But in here, if we look it up, what was it? Store.locale, it's in here. Right? And I don't have to go chasing all these types. So then how do I use it? In the class path of the application you're trying to compile, you create a directory, meta inf native image. The recommendation is you put it under a directory that would not be squashed by something else. So Excel is great.
So we're doing this manually, but you can also feed it as a property to the agent and instruct it to put it in a place that is known to native image.
Right. So I do the drag and drop, but you can configure the agent to do that for you. When I compile, all these hints will be taken into account, and so all my reflection will be registered for me, and Excel will work, and it's going to be absolutely awesome. OK, so TLDR, run the agent. You can run it with Maven. You can run it with Gradle. You can run it with Java if you have a compiled application and you don't want to be using one of the build tools. There are some limitations. So for example, today, AWT doesn't work on macOS. It works on Windows and Linux.
Yep. There are some linking challenges on macOS.
Yes, right. So there might be some very edge cases that might not be working. When I started working on this presentation, Apache POI, our good Excel friend, wasn't working on version 5 and up because of some log4j2 dependencies. Since August, the log4j maintainers have started adding support for native image. So it's getting better and better and better over time. You know, if it's not fully compiling immediately to native, maybe in 6 months, it will be. So go bug the maintainers on their issue tracker, or generate the hints yourself, contribute them to the metadata repository. Will be forever thankful.
But you made a very good point that it's getting much better. So I'm not just saying this because I work on GraalVM, but indeed, like all those questions that I get over the years about libraries working with native image. In the beginning, it was like, can I use libraries at all? And now it comes down to using libraries that do some niche things, such as generating Excel for you. So it does get better over the years. Niche for, OK, general for banks, niche for everyone else. Let's put it that way.
Cool. Hello world, maybe on packaging distribution?
Yeah, about packaging and distribution. So another common question is, can I do cross-platform compilation with GraalVM native image? And the answer is not out of the box, because we need some JDK-specific classes for each platform. So platform meaning I cannot compile on my MacBook for a Linux machine. It needs to be for that specific architecture and operating system. Now, there are multiple ways to tackle this. One is you can build, again, in your CI/CD. For example, I'm a big fan of GitHub Actions. All my projects on GitHub are using GitHub Actions. There you can just configure and build for whatever platform you might need, and either use it yourself or distribute to your users. Another good way around it is to use build packs that is also endorsed by the Spring team that can help you build container images out of your applications.
So if you use container images, you deploy to Kubernetes, to Google Cloud Run, to whatever cloud provider you want, the good answer is using build packs. We will do the right thing for you in many fronts, more than just native. You can control native behavior with flags. Everything is well documented open source. If I build this example app on my Mac and I mount it into an Ubuntu container, it's not going to work. So as Alina said, build it in CI. So for example, I mentioned the Spring Application Advisor earlier on. It's a product we give to our enterprise customers. It has a CLI. We build 5 versions of those in GitHub Actions, and we can distribute to Windows, Mac, Linux, 32, 64-bit, and so on. OK, but why are we doing this?
Let's talk about performance. I've been waiting for this moment.
We're not doing this for the fun of having more work to do that has nothing to do with features. We're doing this because we're trying to get something from it, and that's performance. So maybe while I set this up, maybe you can.
Yes, I will talk about this. So another, again, common question that I get about GraalVM is, what about peak performance, right? So we all know that JVM is great at peak throughput. It's been developed for decades specifically to target peak throughput. So what about native image? And often we have those misconceptions that AOT compiled code will now be as fast as the JIT compiled code, because that one has been dynamically compiled as you go. That's an interesting theoretical topic. I'm happy to talk with you about this during the break. But the thing is, with native image, you can get peak throughput on par with the JVM if you apply additional optimizations that you need to know about. So one thing you need to do is called PGO, that is Profile Guided Optimizations, and that works in a way that you build an instrumented version of your application, run it, apply relevant workloads, and collect profiles similarly to how the JVM collects profiles as you run the application. Then you pick up those profiles when you build a native image optimized version of your application, and it will benefit from having kind of an insight into what will happen at runtime because we collected profiles. So it will do a similar thing to what the JVM does. So PGO is probably the biggest thing that you need to do to get good peak throughput on native image. Two more pieces of this puzzle is if you want good peak throughput, try out the G1 GC in native image. You can use different GCs and compare, but specifically if you want to be running a high-load application that does a lot of allocations, uses a lot of threads, then G1 GC is your probably best shot at it. And last but not least, you can also use the flag called mRc native, and that says, I'm building on this machine, and I will be deploying on this machine, so please use the specific hardware features of this machine rather than optimizing for the best compatibility for all kinds of machines. Now, with all those three flags, we have three versions of our application running. That is a JVM version, native out of the box, and then native with all those boosters that I have mentioned.
So native, this machine is a beast. So I limit how much CPU these apps can use to simulate what your cloud VPS would be doing. So maybe you don't have a very powerful, so it's a bit slower. Here, this application in native starts in 0.8 seconds. This one starts in 0.07 seconds, 70 milliseconds. This one in 38 milliseconds, so 50 times slower to start. So if you're doing cloud functions and you want your thing to be on quite fast, then being on native is going to be already quite a good help. So let's run some perf tests. We're going to generate some load and then look how they perform in parallel. So this refreshes every 10 seconds, so it takes a little bit of time to get the first data points, and we're going to see 3 lines, one for JVM, one for native, and then one for native optimized. So the first measurements, the averages are not so great, but you can see that when you start measuring, the JVM here is about 500 requests per second, in here was 600, and native was 3,700. And native with PGO already 5,300 requests per second. But what you see here is that with native, even without any work, even without PGO, you get peak performance immediately. The JVM, though, warms up. As you hammer it with...
It's expected, right? We expect the JVM to...
It was designed at a time where we would want our JVM to keep running and not relaunch it every time.
But so it could be that it's critical for you to have good peak throughput in those first milliseconds. From talking to customers, we have some of them who say it's very critical for us that there are absolutely instant response time. So this is something native image can give to you. And now I think it's fair to say that the JVM is warmed up, or like it's reaching the place where it's warmed up. And you can see how native image optimized, I would say it's on par with the JVM, right? So I think this is the main conclusion from this benchmark that we are running, that in addition to memory savings and startup time that we talked about, you are not really losing peak throughput comparing to the JVM. It might vary. We always say, test responsibly, benchmark responsibly, but overall it is on par with the JVM, so you're not losing peak throughput, only you are winning startup times and memory savings.
Yeah, this is a garbage benchmark. We just want to show you.
Quick and dirty benchmark. Benchmark on your own applications. Don't take our word for granted. But hopefully, this illustrates the point that you can get peak throughput on par with the JVM if you apply all the optimizations.
And it's trade-offs, right? So the JVM takes, she said, milliseconds for first responses. This takes about a minute to get warm on this machine. So without any work, I already get peak throughput. If I apply a little bit more work with profile-guided optimizations, then I'll get comparable results. OK, maybe a few takeaways for the session?
Yeah, so let's summarize. So hopefully we covered in this session how with native image you can get fast startup, but also instant performance if it's really critical for you in those first milliseconds of your application running. Now, startup times alone, another big benefit is lower resources consumption. So if you're deploying your applications to the cloud, you know that you're paying for what you are using and how long exactly you're using that. But also maybe you care about the planet and the forest and the turtles, so you don't want to burn resources you don't really need. That is another place where native image can help you and save you somewhere around 3x, 5x less memory usage. And last thing is compact packaging. If you want to have smaller executables or smaller container images, that's also something that native image can give for you.
So recommendations, latest and greatest. Even if you are not allowed to deploy GraalVM or like JDK23 in your environment in prod, you can do your migration using 23 because the compile times are going to be better. And so you're going to have a better experience. And then when you are finished migrating, you can go back to whatever is approved within your company. Use the latest Spring Boot. The libraries get better support. Spring Boot gets better support, get better performance. So keep upgrading. Develop and test, do test on the JVM, and then compile close to what you're deploying to. And we have 3 seconds. So please, if you're on YouTube, like, subscribe. If you're in the room, rate this talk. Thank you for your attention.
Thank you for coming. And please consider staying. There is one more GraalVM session from Fabio and Thomas, I think, in the same room. So if you want to learn about Python, all things polyglot, it will be in the same room. So we are staying. Consider staying as well.